Hi guys, welcome to Let's Get to the Marks. Let's get into it then. Today going through lipids for biology A level. It's not a long lesson, so should be nice and easy. Yeah, you may have already done quite a bit on lipids at GCSE, so it's just expanding on that a little bit further. Later on in the A-level course, when you study digestion, you'll get into lipids even more, and when you look at cell membranes as well. So it's the same, the lipids content is the same whether you're studying EdXL, AQA, or OCR. So all exam boards, it's absolutely the same. So let's get into it. Lesson 2, biology A-level. What's another name for lipids? So obviously, lipids have more than one name, and another name for lipids is fats. So you'll have heard of lipids just in the public domain. People just know of them as fats. Of course, as a scientist, we call them lipids. Now, what are the uses of lipids? So there's like three main uses of lipids within organisms that we need to think about when studying lipids. So what are the three main uses of lipids? Well, we've got energy storage is one. So for storing energy, unfortunately, I'm storing a lot of energy. I need to lose some of that. But also for insulation, so keeping organisms warm. Lipids are good at insulating and reducing heat loss. And the third one is for membranes, including cell membranes and membranes around other organelles. So you might just think of membranes being around the outside of the cell. And as you know from GCSE, the cell membrane controls what goes in and out of the cell. But at A level, we learn that there are membranes around many things. So all the organelles within the cell have their own little membrane. So whether you're looking at mitochondria, chloroplasts, or the nucleus, they have a membrane around the outside. So it's not just cell membranes, but all membranes contain lipids. Okay, so moving on. A lipid that you will have to become familiar with, and one of the most important ones in living organisms, is known as triglycerides. And these are what we called lipids at GCSE. Now, at GCSE, you learned that lipids are made up of three molecules. So can you remember the three small molecules that lipids are made up of? Feel free to leave a message on the chat if you know the name of any of the small molecules lipids are made from. Okay, so lipids are made of a glycerol molecule and three fatty acids. So a total of 4 molecules to make one triglyceride or lipid molecule. Now, just turning down my headphone volume, because I'm probably blasting out people's ears. So, are lipids polymers? If you were with the chemistry lesson that I did last night, you'll know that polymers are, or in the biology lesson 1 actually as well, we covered that. Polymers are very long molecules made of many small molecules, many monomers. Well, a lipid or a triglyceride is only made of 4 molecules. So it's a large molecule, but it's not a polymer. What type of chemical bonds hold the small molecules in lipids together? So what we're looking at here is really this bond here. So what type of chemical bond, you might remember from GCSE chemistry, do we show with a straight black line? And the type of bond we show with a straight black line is a covalent bond, and most of these bonds are covalent bonds. Covalent bonds are very strong bonds, so they're very useful in biological molecules. And this specific bond has a name, and it's known as, can't even spell. Tri meaning 3, by the way. Triglycerides. I don't think I've spelled that right. Oh my good gosh, my spelling is so bad. So in triglycerides, the bonds holding the molecules together are called ester bonds. Now, I'll be a bit more specific. It's the one that I've highlighted there. There are some other bonds in triglycerides that aren't ester bonds, but this one I've circled in red here. This is an ester bond, and this is what holds the molecules in triglycerides together. Okay, now the tails of triglycerides are hydrophobic, and what does hydrophobic mean? Hydro, what does that remind you of? Phobic, what does that remind you of? So my mum is an arachnophobic. She's scared of arachnids, spiders. And yeah, you can be a claustrophobic. You're scared of like enclosed spaces. Or you can be hydrophobic. You might think scared of hydrogen, but it means scared of water. Of course, water has 2 hydrogen atoms in it. So hydrophobic means repelled or repulsed by water. So doesn't like water, water hating. And the tails on the triglyceride, those 3 blue tails, I've colored blue there, they're not really blue, but they are actually hydrophobic. They're like, get away from me when they come near water. So they repel water. They push water away. They don't like to interact with water. Right. Is that everything? Let's move on. Okay, glycerol. Just for those of you that are like to spot things, as biological molecules is biology, but it has some links with chemistry. It's actually a form of another topic called biochemistry. If you go to university and study that, it's a mixture of biology and chemistry. And this series of this unit within the biology A level series of units, whatever I'm on about, who knows, falls within a topic called biochemistry. So that OL, you might remember that from alcohol, ethanol, propanol. Glycerol is actually an alcohol. In chemistry, that would be described as an alcohol, along with paracetamol that you take for headaches, or cholesterol that's in your body. Okay. So glycerol, of course, in chemistry, it's an alcohol. So here's the triglyceride once again, just over here, made up of 4 molecules, a glycerol molecule, and 3 fatty acids. Now, if we look a little bit closer at the glycerol molecule, so I'm going to circle that here in red. This is a nice easy diagram. So this is a simple diagram, and in exams and in your notes, you'll need to know this diagram of a triglyceride and what each part is. And in this simple diagram, it's nice and easy. However, there is a slightly more complicated version, and those of you that go on to do A-level chemistry or take A-level chemistry, you'll get used to this. This is called the displayed formula, and this shows all the covalent bonds within a molecule. Of course, I haven't showed the bond between the O and the H from the hydroxide groups there on the glycerol. And this is what glycerol looks like if we look at all the bonds. So it's made up, glycerol, of hydrogen, carbon, and oxygen. And it's got those OH groups. It's an alcohol. In fact, if you're a chemist, its name is propan for the 3 carbons, 1, 2, 3, triol. So it's propan, 1, 2, 3, triol. That's the name, but in biology, we just call that glycerol, okay? Now, the glycerol molecule joins in a reaction called condensation, and we discussed this a little bit last week when talking about glycosidic bonds forming between monosaccharides to form disaccharides and monosaccharides to form polysaccharides when we were looking at carbohydrates. You can check that out. That's the A-level biology lesson 1. And what happens here is we have another molecule here. Now this molecule represents over here This is this molecule over here, and this is a fatty acid. Now you need 3 of these molecules, these fatty acids. You need 3 of those to join with 1 glycerol, and they make a triglyceride. Now, how do they do that? They do that by a reaction called condensation. And you'll remember that from last week. Really, what happens in a condensation reaction is an H and an OH. Anywhere that you can find a water molecule can be formed, snap off, and the bonds join. And in fact, it's probably more sensible for me to join that with this one here. And then 2 more of these green fatty acid molecules I've joined would come down and join to the others. We call that a condensation reaction. Now, it's pretty long drawing all of this out, and when you're studying biology, biologists aren't interested in drawing all the bonds out. We leave that for the chemists. So there is a shorthand way of writing a fatty acid, because this section of the fatty acid chain, so this part of a fatty acid molecule can be any length. That could have 100 carbon atoms in it. So you get all different types of fatty acids, some with 20 carbons, some with 10 carbons, some with 50 carbons. So fatty acid chains can be all different lengths. And so we can just represent that with like an algebraic symbol that we use in biology to represent side chains. And we can do that like this. So we can shorthand the fatty acid. We show this part. This is the important part that is involved in the condensation reactions. And then we show an R. So we can simplify this. We can show as an R. We call this an R group. It's a type of side chain. Okay. And it just saves you having to draw all the carbon atoms out. And if 3 of these fatty acids come along and the water molecules snap off, you can have a go. If you want to pause, if you're watching this on rerun, you can pause the video and you could try on a scrap piece of paper, try and write out what the glycerol will look like once it's joined with 3 fatty acids to form the triglyceride. It'll be good revision practice. And I'm going to click the slide on and we're going to see what that looks like. Okay, so when these guys join together, and when 3 of them join like that, that water molecule is going to snap off, and we call that condensation when that happens. And actually, we're going to lose 3 water molecules in this condensation reaction. So we're going to lose 3 water molecules there, and that's called condensation because you'll literally see water appear. And it's going to produce this. And what we've done here is, instead of having to do the long bit of draw all those carbons and hydrogens, we've just put an R. So that R represents what I've circled in red there. That's the R group, okay, the side chain of the fatty acid. Now, this here is our triglyceride, and you can draw it in the way with the 4 rectangles, 1 on the side for the glycerol, 3 black lines for the bonds, and 3 rectangles for the fatty acids, or you can draw this long version out. And again, this isn't the longest version. The longest version would be if you drew all the R side chains out, but that would take you 5 to 10 minutes, and they're not really interested in testing that. So this is a triglyceride, and it's formed by condensation reactions. Now, bada bada bing, bada bong, bada bang. The opposite of this condensation reaction is hydrolysis. And this is if we go this way, we can reverse this reaction by taking our triglyceride and we can turn it back into 3 fatty acids and a glycerol molecule. And we can do this by a reaction known as hydrolysis. Hydro, meaning water again in this situation rather than hydrogen. Lysis. Lysis means breaking. So hydrolysis, using water to break. And actually, this is why you have to have water in your diet, and why you would die if you didn't have water for 3 days. most humans will die without any fluids for 3 days because we need water to break bonds. And when you break chemical bonds, you release energy, respiration, which gives us the energy to do all of the Mrs. Gren stuff: movement, respiration, growth, excretion, all of that stuff, sensitivity. We need energy for all of those things, which you're going to learn about in A-level biology. So water is essential for all living organisms because it's needed for hydrolysis reactions. Even bacteria, those tiny little single-celled microorganisms, need water to break down triglycerides or polysaccharides into smaller molecules that they can then use to release energy. So yeah. Right, let's move on. Bada bada bing. Boom. Right. As I say, it's going to be quite a short lesson today because it's quite a small topic. The basics of this. I'm just going to shrink my fat face. Brump, like that. Lots of stupid noises coming in. Okay. So we got saturated versus unsaturated fats. Which is healthier? Why? Well, here you can see I have some butter. You also can include cheese in this. Solid fats, those are normally saturated. And what we mean by saturated, let me rub this out. You might remember from your alkanes and alkenes that you did in GCSE what saturated means. Saturated means only contains single bonds. So if we check out, this is a fatty acid side chain. Okay. Now, this is a chain, and I haven't bothered drawing all the hydrogens on, but I could stick all the hydrogens on now like this so that you can fully see it in all its glory, but it's quite long. So back in my day, long time ago, it's about 30 years since I took my A-levels. And when I took my A-levels, you didn't have to include the hydrogens when you did the displayed formula in your exams. They just said, yeah, the student knows that hydrogen is on the end of each of these. Wow, that took a long time. So that is a saturated fat, and it has no double bonds. So the definition, this is a saturated fatty acid or saturated fat, and you find this in solid fats like butter, lard, animal fats mainly, things from animals, so cheese, which comes from cows. Fats like from animal products are saturated. They don't have a lot of double bonds. And what does that mean? How does that affect us? Well, check out the olive oil down here that's liquid. Essentially, when you have a double bond, and we've got unsaturated fatty acid tail here. Remember, these fatty acid tails are attached to the glyceride in a triglyceride, but when you digest them, they become, the tails separate from the glycerol, so you end up with 3 fatty acids. Now, those fatty acid tails could be saturated or they could be unsaturated. Look at the shape of the unsaturated one. What you'll notice is that where there's a carbon-carbon double bond, which is what makes this chain unsaturated, it's straight, and this creates kinks, as we call them. So the normal carbon atoms with a single bond can spin and rotate around each other. There's rotation around single bonds, but double bonds are rigid structures, and the carbon atoms can't rotate, so they're locked in place. What happens here is that we end up with kinks and bends in unsaturated fatty acids because of the carbon-carbon double bond. And why is this a good thing? Well, it turns out that the different fatty acid chains can't get close to each other. Therefore, they have a lower melting point and a lower boiling point. More important is the lower melting point, which means that at room temperature, like in the room right now where you are, if you have an unsaturated fatty acid, it's going to be a liquid like olive oil or avocado oil. Now, why is that important? And most vegetable oils. You know, you've probably seen your mum or your father cooking with oil, vegetable oils like olive oil, coconut oil. You probably put some coconut oil in your hand. It melts just from the heat of your hand. You go Costco, you get a big fat tub of that white coconut oil. Well, it melts in your hand easy. That's because it has a lot of unsaturated fatty acids. And they have these kinks which lower the melting point. Why is that a good thing? Well, when you consume fats, if they stay liquid at 37 degrees in your body, then they're unlikely to build up and clog up your arteries. And if you remember from GCSE, fatty deposits can cause atherosclerosis, or they can build up and form a plaque, which can, oh my God, I'm spitting all over my computer, which can lead eventually to a thrombosis and a heart attack or a coronary heart disease. So unsaturated fatty acids are less likely to do that. Saturated fatty acids have higher melting points, hence why butter is solid at room temperature. This means they're more likely to form solids in your arteries and clog up your arteries, reducing blood flow to the heart, leading to coronary heart disease. So it's kind of healthier to have lots of unsaturated fatty acids in your diet. That's not to say that a moderate amount of butter isn't good for you. It certainly is. It's certainly better than a lot of those margarines, which have been hydrogenated, and they have their own problems because of that. But naturally unsaturated fats like olive oil that come in that form naturally, they haven't been chemically altered, they're very healthy for you. So I've got some notes on that here, which I'm just going to put on the screen in case you're a note-taking person. So just going to move my picture of my butter out of the way. Butter. And my olive oil. So this basically explains what I've just been waffling on about. Double bonds create kinks, which lower the melting point. So unsaturated lipids are normally liquid at room temperature. Think of olive oil, whereas saturated fats are solid at room temp as they have higher melting points. They are more likely to form solid fatty deposits in the blood, leading to atherosclerosis. Sclerosis means scarring. Athero is like of your arteries. So we call these little bits where the fatty acid chain bends, we call these kinks in the chain or bends in the chain. And that lowers their melting point. I think I might have gone on a little bit too much there, so it's probably time for me to
You better move on, or else.
yeah, thanks for the reminder. Time to move on, eh? Right, before I send anyone into deep sleep. Why are lipids good energy stores? So, why are lipids good stores of energy? Think about it. Look at the amount of bonds they have. Lots and lots of bonds. That R group there could have 20 carbons in it. Lots and lots of chemical bonds or covalent bonds. Lots of bonds which, when they are broken, think back to your GCSE chemistry days, bond making, bond breaking. And all of that. Lots and lots of bonds which can release lots of energy. So when they break down, if it's exothermic hydrolysis, it's going to release energy overall to the environment. And that energy can be used by our body to do lots of things. So lots of bonds which store the energy as well, I could put there. Lipids are insoluble. Why does this make them good for storage? You might remember me talking last lesson, linked to the previous lesson, and the polymers that we store in our body, like carbohydrates, which ones? So we store polysaccharides like glycogen in our liver and our muscles. Glycogen is also insoluble. And that's really good because it means it doesn't affect osmosis. We don't want water moving in between cells when we store stuff in them. Otherwise, it can cause the cells to swell up and burst. So it's a very good thing that lipids are insoluble. It makes them good for storage. They do not have an osmotic effect. Now you can describe that. That's a good term, an osmotic effect. It means, so if you wanted an explanation of that, they do not lower the water potential. because hi Ali Imran, yeah, if they lower the water potential, then that's going to affect stuff. Yeah. Uh, Coolio. Yeah. Are you going to take A-level biology, Ali? Yeah, RQ and R, yeah, that's right. Osmotic means osmosis. So the fact that they're insoluble and they're stored within cells and stuff means that they're not going to cause water to move in and make cells swell up and explode. If you move glucose or sugar or salt, soluble things, into a cell, they lower the water concentration. At GCSE, we say water concentration, but at A level, we use the word potential. When we come on to that, you'll see that. So they lower the water potential, and that will cause water to move from a high water potential outside the cell into the cell, causing it to swell up and explode. We call that an osmotic effect. So when you want to store stuff, it's best to make it so it isn't soluble in water, then it can't change the concentration of the water or the water potential. So that's why lipids are really good. In fact, another thing about lipids, which is why I'm fat, is lipids contain twice the energy of the same mass as carbohydrates. It's not quite twice, but yeah, it's a lot more. So what does that mean? Our bodies, by natural selection, remember you did that at GCSE, our bodies have chosen, well, they haven't really chosen, that's a bad term. Nature has selected, which is much better, fat to be the storage molecule. Why is that? People or organisms that stored most of their energy, excess energy, as carbohydrates. So if you eat 3 pizzas tonight from Pizza Hut, right? If you eat 3 pizzas, you're not going to burn all that off. You're not going to use all that energy. So the body says, right, what do I do with those extra pizzas? I need to store them in the body. Now, organisms that store that as carbohydrate, there's less energy per gram of carbohydrate, which means you're going to have to put on a lot more weight to store that. And that means you're going to be slower, less efficient, more likely that a lion's going to catch you and eat you, or a shark, or you can't swim away from a shark, so you're going to get eaten. So over thousands of years, organisms that stored the excess energy as fat, as you can store more energy in 1 gram of fat compared to 1 gram of carbohydrate, they'd be lighter and more efficient, able to escape, able to hunt, able to do all these things. So it was just more efficient, and therefore to store energy as lipids or fats on the body. So that's why when you have excess energy, you store it as fat. It's actually because it's a good thing tradition in the past. Now we've got Tesco's, Sainsbury's, and food everywhere. And starvation is not likely in most places, then it's a negative thing, but because you're likely to get heart disease from carrying too much fat on your body. But when there was hardly any food and starvation was a problem, then of course the ability to store fat instead of carbohydrate would be a super advantage and make you more likely to survive and pass your genes on to your offspring when you reproduce. So we can blame natural selection for why we store fat. Right. This is called a phospholipid. Now, I don't know if you were here at the start of the lesson, but I'm going to zing quickly to here. This here that I'm circling over here, this is a triglyceride, and it's made of, this is what you learned about and called a lipid at GCSE. It's made of a glycerol molecule and 3 fatty acids, okay? And it has these bonds called ester bonds that are in between. Now, talking about that, the ester bonds, which I didn't highlight, big no-no not to highlight that, so it's a good thing. This is the ester bond which is formed. So that bond there is the ester bond. So we talked about glycosidic bonds in carbohydrates between the glucose molecules or the different types of monosaccharides. They're ester bonds in triglycerides or lipids. You have to know the name of them, and they're ester bonds. Now, zinging back here, this phospholipid is slightly different. Can you see what the difference is between this phospholipid and a normal triglyceride? What's the difference? How many tails does the phospholipid have compared to the triglyceride? Yeah, RQ&R, there's a difference in the tails, the number of tails. We call them a tail. They're not really a tail. They're fatty acids. So we can just call them a fatty acid tail. How many did the triglyceride have, and how many do the phospholipids have? This is just another type of lipid you need to know about. How many fatty acids are in a lipid normally? Watch me zing back. Super speed. There it was. Look at the triglyceride. How many tails or fatty acid tails do they have? 3. Yeah, nice. So they got 3 fatty acid tails. If we go over here to our phospholipids, there are only 2 fatty acid tails. So you can often be asked to compare them. So phospholipids have 2 fatty acid tails. But we can also say compared to 3. But we can also say that both have fatty acid tails. Great, yeah. So the hydrophobic tails are on both. They're always hydrophobic. I'll explain that. That's a good point. Thanks for that. Hydrophobe. What do you think hydrophobe means? What does phobic mean? What does hydro mean? Yeah, very good. Doesn't like water. The phobic means hate, like you can be an arachnophobe. Yeah. So doesn't like water. Yeah. Have you ever got oil on your hands? Like if you've been cooking or you got olive oil or coconut oil, if you're moisturizing yourself after a bath, you get oil on your hands. You can't really wash it off. Like it's really hard to wash off because water just repels off of it. And so that's why, because of the hydrophobic fatty acid tails, to give them their full name. Now, phospholipids have something extra. What did you notice about this drawing that's there that's extra? What is there extra there? Thank you, Ali Imran. There is a phosphate group. Now, the phosphate group, guess what? This is known as the phosphate group. Forms a water-loving head. Why a head? It's just a word we use. So the phosphate group is a water-loving molecule. So it loves water. It's attracted to water. What do you think we call it instead of, well, instead of hydrophobic, we call it hydrophilic, and phil or phile means love. So hydrophilic, it's sometimes called a hydrophilic head. It loves water. So triglycerides just don't like water. Olive oil, coconut oil, all of those don't like water. However, phospholipids are slightly different. They have a water-loving bit and a water-hating bit, okay? And this really helps them with their function. So they're slightly different. So if we were comparing them, we'd say, oh, phospholipids have 2 fatty acid tails compared to 3 on triglycerides. But then we could also say, both have fatty acid tails. That's a similarity. However, phospholipids have a phosphate group. So that's a difference. So there's some differences there. Both have ester bonds. If you're wondering what an ester bond is, it's this bond right here. If you weren't here when I was going over ester bonds, these are ester bonds. So when I did carbohydrates last week, if you haven't checked out last week's video, it was on carbohydrates. So you can check that out. Carbohydrates like glycogen, cellulose, they have something called, or starch, amylopectin, amylose, they have glycosidic bonds. When we're talking about fats, they always have ester bonds holding the fatty acids and the molecules together. So, and they're formed by condensation and broken by hydrolysis, just like in carbohydrates. Now, what else? Another thing, if I'm comparing them, both are made, so there's lots of similarities. Both are made both contain carbon, hydrogen, and oxygen. So, yeah. However, a difference, obviously, we've pointed out. So they contain the elements carbon, hydrogen, and oxygen. Right. What are the hydrophobic tails? Just thinking of anything else I might have missed out. These here, these saturated fatty acids and unsaturated fatty acids, you can see here that I went through just like 5 minutes ago. These are tails. There'll be 3 of them on a triglyceride, 2 on a phospholipid, and they could, all 3 could be unsaturated or all 3 could be saturated. This unsaturated fatty acid with the blue circles, it has carbon-carbon double bonds. You'll remember them from alkenes in GCSE chemistry. This is actually known as a polyunsaturated fat because it has more than one double bond. If it had one double bond, we'd call it a mono unsaturated fat. Whereas the top one is fully saturated. No carbon-carbon double bonds in sight. Something else, when you see this group here, this is always found on each fatty acid. Look, there's another one there. These have the formula COOH, and this is known as the carbonyl group. So these are known as the carbonyl group. Yes, and it's biochemistry, this topic of biological molecules. So it's a little bit like alkanes and alkenes. But you can watch back through the video if you like to see the other bits that I covered already. There's not too much to it. Phospholipids are really important in cell membranes. So at GCSE, you just learned that membranes control what goes in and out of the cell. At A level, there's a whole unit, which we'll be covering in a few weeks, on the cell membrane. And just to show you, these are the phospholipids. Here are the heads. That's a phospholipid. This is a cell membrane or a membrane around a nucleus, it looks like, because there's DNA in there. There's lots of other things inside the membrane, but we won't do that till we get onto it. This is the water-loving head. This is the water-loving head, the phosphate group. And the tails hate water. Yeah, very similar. Not quite the same, but very similar. Yeah. And even the mitochondria have a membrane like this, and chloroplasts. Some have a double membrane even, and go even further. They've got 2 membranes around them. So they have double membranes. Now, these are the fatty acid tails, and these hate water. Okay, they're the proper term instead of hating water is hydrophobic. Oh my gosh, I hate writing. Right, it's hydrophobic. So we've got water-loving heads on the phosphate group, and we've got fatty acid tails that hate water. Yeah, so the difference with the cell membrane is it has a lot of other structures in it, and we'll go into a lot of detail about that when we come to the cell membrane. But this is just showing you how they line up. Now notice there's 2 layers of them. They look like little sperm cells actually, but they're not. They've got like multiple tails, which are the fatty acids, the 3 fatty acids. And then you've got the glycerol and the phosphate group. Notice the way they've lined up. There's 2 layers of them. So they've lined up like that with the heads facing this way, tails that way. And then another line of them has lined up with their tails like that and heads out. Why do you think they need the water-loving heads? Why do they need these water-loving heads on the outside and inside of the cell? Or organelle, nucleus, whatever it is. So Ali Imran, that is a good good suggestion. So well done. Yeah, it's not so much they do absorb water, cells actually, but the water has to be controlled. So some cells have special proteins called aquaporins that let water in. But well, it's because they need to be able to interact with the water. Do you remember, like, your body is like, I don't know what the figures are, you have to look them up, but 65, 70% water or something like that. Your cytoplasm is mainly water. So inside the cell is mainly water. Your cells are not like bricks in a house. There's actually a liquid that they're all floating in. And so there's water outside the cell and inside the cell. The water outside the cells that our cells are floating in is called tissue fluid, body tissue fluid. And our cells literally float in it. Yeah, so we're mostly made up of water. So it's important that our cells aren't repelled by water. So the outside of the cell and the inside of the cell can interact with the liquid around them without repelling and moving away from it. But we've got this water. We've got this layer that's insoluble and hates water in the middle. So this stops the water just rushing into cells and swelling them up. It gives some control over what comes in. It won't let certain things enter your cell. Anything water soluble like salt or sugar can't just move into your cell because this bit here, which hates water, will not let anything that's dissolved in water move in. So it's like, hey, sugar, you ain't coming in. Salt, you ain't coming in. So anything that is soluble in water can't come in just straight across the membrane. It has to go through special gates and channels, which we'll learn about when we cover the cell membrane. So that's why we say the cell membrane controls what goes in and out. Its structure helps it control that. So yeah, that's the way these lipids line up, and these phospholipids, and it enables, if they were just made of triglycerides, it wouldn't work because they couldn't interact safely with the water outside and inside. But because there's a water loving bit on phospholipids, the cell membrane is happy to sit there in the water because the outside and inside of it love the water, essentially. Right. Do you guys remember any of the tests for lipids? Do you guys remember any of the tests for lipids? Ooh, ethanol's involved. Ethanol's involved. Do you remember the name of the test? Ethanol is involved. Well done, Ali Imran. You get a white precipitate. I'm going to give you an applause for that. Yeah, well done. You get a white precipitate and you need ethanol. Absolutely. Do you remember the name of the test? It's called the emulsion test. And we need to know that again at A level. Whoopsie. And essentially your keywords or your key points are, yeah, mix with ethanol and then pour into cold water. The water's got to be cold and then you'll see a white precipitate. Nice. Well done. Right, going to go through some exam questions. So these are some A-level exam questions. So just going to shrink my fat head down. My lipid head, or triglyceride head, I should say. So, yes. Okay. The diagram represents a triglyceride. You might remember from GCSE, what are lipids made of? So what's box P and what are the three Qs? What are lipids made of? Remember, lipids or fats are broken down by lipase, or lipids broken down by lipase to form what? Three fatty acids. Nice. But what would be the three fatty acids, P or Q? Obviously, yeah, the three fatty acids are Q and glycerol. Nice. Awesome. Yep. Perfectoid. Now this is something that these bonds here, you need to know what is the type of bond found between P and Q. A girl's name beginning with E. I'll just wait a second to see if you can get the name. If not, I shall put the answer on there. Yay, on fire. Ester bond. Some people call it a link or an, yeah, it's the ester bond. And the ester bond, actually, you probably covered in your organic chemistry when you did esters. So if you did esters in organic chemistry, you'll remember, as he messes the ester bond up completely, I think, oh my God, that is the worst ester bond in the history of ester bonds. So it's like OCO, something like that. Oh, thank you. COO. That looks a lot better than mine. COO. Yeah. Ugh, I think I've drawn that pretty disgusting. All right. Well, we've already just done this. Describe how you test a lipid sample for the presence of lipid. So going over here, ooh, what's the group represented by COOH? You might remember from your GCSE chemistry if you did triple science. Jeez, dude, you're on fire. Yeah, absolutely. Absolutely right. Yeah, that's the carbonyl group. Group or carboxylic acid group. Yeah, so that's why they're called fatty acids, because they have an ester bond, but they also have, on the fatty acid, there's always a carboxylic acid group. So, okay, well, they have an ester bond when they form a triglyceride. They don't have an ester bond till then. Yeah, some of this is GCSE, so some of it transfers over. Name the type of R group shown in figure 1. Okay, this bit's GCSE as well. You might be saying, what the hell? What could they be on about? What type of fatty acid is this? Fatty acid side chain. This is an R group, which is the chain of a fatty acid, which we can show with an R. Any ideas for this? Okay, so I'm going to zing back. Oh, God. Went a bit far there, didn't I? I'm back to Google. I'm Googling. And I'm back. Yay. I got a bit excited with the old clicking the old button there. Right. Yep, we're back. We're good. Okay, so these fatty acid chains over here, I've got an R group. So the fatty acid tails, the hydrophobic tails, we can just put an R on them. Now those fatty acid tails come in two flavors. Okay, so you can see here circled in red over here, these are the R groups. They come in two flavors. You've got saturated ones, which have no double bonds in them. And you've got unsaturated ones, which have double bonds in them. Unsaturated fatty acids, it's better when you're eating your fats to have unsaturated fatty acids. So I was talking earlier about this coconut oil, olive oil, things that are liquid at room temperature. It's because they have lots of these carbon-carbon double bonds. That lowers their melting point, makes them less likely to build up and cause fatty deposits in your coronary artery, which reduces blood flow to your heart. So saturated fatty acid tails on your triglyceride, found in butter and cheese and animal products, those are more likely to form fatty deposits and lead to heart disease. So yeah, that's a bit GCSE. But if you go here then, back here, is this an unsaturated or saturated fatty acid? That's essentially what it's asking in a sneaky way. Awesome. And what would be your explanation? So what would be, how would you justify your answer there? Why did you say unsaturated? Good. Double bond. Now, at GCSE, they just allow you with the double bond. Always better to mention that it's the carbon double bond, because you can have one of those C double bond O's. They don't count in the old, are you saturated or unsaturated? Right, here are the answers. So you'll see here, the answers here for the how to do a lipid: mix with ethanol, pour into water, white emulsion. Ooh, it says reject precipitate. Oh, disgusting. Right, so we can't write precipitate. Check that one. You have to say white. It goes white or milky emulsion. So we're not allowed to call it a precipitate. You only learn these things sometimes by doing the exam questions. It's why they're so good practice. So this is known as the carboxyl group. Going to change that. Carbonyl group is the COO, not the COOH. So the carbonyl group is just the C with the double bond and the O. The carboxyl group is COOH, or the carboxylic acid group, which you called it anyway. Yeah, great. Cool. One more of these before we finish. So next week I'm going to do proteins. So biological molecules is basically carbohydrates, lipids, proteins, and then it's water and DNA and RNA. And then that's our biological molecules done, which is a fat piece. It's like 1/8 of the whole A level. But yeah, they can get quite difficult. Proteins is quite a fat topic, so I'll probably take 2 lessons on proteins. Nearly finished. Fatty acids, caprylic acid. Okay, whatever. There's 4 different. I can't bother to read it. There's 4 different fatty acids: caprylic acid, palmitoleic acid, stearic acid, linoleic acid. This says the number of carbon atoms in each: 8, 16, 18, 18. The number of double bonds in the R group: 0, 1, 0, 2. which one of these statements is actually true? And I need to move my camera. So which one of these statements is true? We've also got a picture of each, K, L, N, and M. So it says caprylic acid is an unsaturated fatty acid represented by L. Is it part of the Q? So the R groups I covered earlier in the video. R groups are the bit of the fatty acid chain. So you see here, this is the bit that would join the glycerol. This is the carboxylic acid part of every fatty acid chain. There's a carboxylic acid end. That makes it the acid. Then the fatty bit of it is this long bit that's just made of carbons and hydrogens. Now they can have double bonds and they're unsaturated, or they can have single bonds. We just call that the R group. Why? Because sometimes we can't be bothered to draw all of those carbons and hydrogens out, and we can just write an R, meaning it's the side chain bit, the bit that's just boring, made of carbon and hydrogen. So that's what the R group is. So it's saying here, how many carbons are in the R group? Well, so we have to see which one of these is true. So we say caprylic acid is an unsaturated fatty acid, and it's shown by diagram L. So we look at it and go, the number of carbon atoms in caprylic acid is 8. Let's go to diagram L. How many carbons are there? At each one of these ends of these lines is a carbon. So this is definitely false, because there'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 carbons in that chain. So that one can't be the right answer, because caprylic acid is supposed to only have 8. So this is more of an applied question. You're applying your knowledge here. The next one says linoleic acid is a saturated fatty acid, meaning no double bonds, and is shown by diagram N. Well, linoleic acid should have 18 carbons in the side chain. 1, 2, 3, 4, 5, 6, 7. So it can't be this one. It is saturated, so that have caught some people out there. But there's only 7 carbons here, and in the table it tells us that linoleic acid should have 18 carbons. I can't even say that. That's just so disgusting. Palmitoleic acid or palmitoleic acid, finally got it, is an unsaturated fatty acid represented by K. So if we check that one, it should have 16 carbons and 1 double bond. I think this one's going to be right. Look, there's the double bond. So that bit is definitely right. It's got a double bond. Then we just need to add up the carbons. Essentially, these are known as skeletal formula. And there's a carbon at the end here of each. So that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then there'll be 16. So there's 16 carbons in K. So that is right. And there's 1 double bond. So the answer for this one was there. So that was quite a difficult question. And then part A says describe how a triglyceride is formed. So going back to the notes on how a triglyceride is formed, what do we call the reactions when bonds are made and you take small molecules and join them together to make a bigger molecule? We did this in carbohydrates if you saw that lesson. And they are condensation reactions. And how many glycerols join with how many fatty acids when we form a triglyceride? So that's what, whoops, gone one too far. That's what this question is saying. Describe how a triglyceride molecule is formed. And the answer to describe how a triglyceride molecule is formed is one glycerol with 3 fatty acids. So it's saying when we form a fat, it's the opposite. You know, when we say lipase breaks down lipids into 1 glycerol and 3 fatty acids, it's saying if you were to make a triglyceride, basically when we used to say lipids at GCSE, we just call them triglycerides now in the main, although there are phospholipids, but we mainly say triglycerides. So it's made of 3 fatty acids and a glycerol. And when we make things in biological molecules, we call it condensation reactions. You use water and the bonds formed are ester bonds. So 3 water molecules would be needed to join together 3 fatty acids to 1 glycerol, and it would form 3 ester bonds. And then over here, this is a proper diagram of a triglyceride molecule. Here you've got the ester link or the ester bond. Remember, you told me it was a COO and you were right. There's the ester bonds. And that was a glycerol molecule before it lost 3 water molecules and joined to those 3 fatty acids. Notice each fatty acid chain are not identical. You can have, we've got some that are saturated, we've got an unsaturated one. So a triglyceride molecule is formed. How many molecules is a triglyceride or a lipid made from? How many individual molecules was this made from? We're nearly finished, by the way. We're going to finish in 2 minutes. So what do you reckon? How many original molecules make a lipid? Any idea? So we got one here, that's the glycerol. This was from the glycerol. And these 3 are the fatty acid side chains. So the total amount of molecules is 4. And then the final question of the night, the structure of a phospholipid is different from that of a triglyceride. Can you state 2 ways that a phospholipid is different? If you can remember that phospholipid diagram. And then we're finished. You're not doing chemistry, are you, Ali? Because I did chemistry on Monday, and I'm going to do chemistry on Monday nights, and I'm going to do biology on Tuesday nights. Cool. So checking out my chemistry videos. I did the first one on Monday at 8 o'clock. I'm going to do a chemistry video. I'm going to go through the whole course, and then I'm going to do a biology video. So this is the second biology lesson. We're going to do the third next week with proteins. Cool, cool, cool. Yeah, there's only 3 so far. I've got 1 for chemistry, and this is the second biology. So Monday nights at 8 is chemistry, and Tuesday night at 8 is biology. Hi, Adam. So I'm going live every Tuesday at 8 for biology, and every Monday at 8 for chemistry. And yeah, I haven't started physics yet, Adam, but I might start doing physics as well. I've got to work in the time. I've got to see how many people are in the lives and see if it's worth doing. Obviously, it's the summer at the moment, so there's not going to be a lot of people studying. Like you just went through some hectic bit before your exams. Most people are going to chill, but I'm expecting in September it'll pick up, and then I'll keep the ones that are going strong. But I will start probably physics in a few weeks. But every Monday is chemistry at 8. Every Tuesday is biology at 8. And yeah, I'm probably going to do physics, Adam. Now, are you doing chemistry and physics, Adam, or just or are you doing just physics? All right, see you later, Adam. And basically, the answer to this, the differences in the phospholipids, for those people who were answering that, A phospholipid has a phosphate group and it only has 2 fatty acids. So that's the difference between a triglyceride and a triglyceride and a phospholipid. Physics only. Cool. Cool. And yeah, all right, guys. I am going to chip off. So
okay, guys, it's late. Time for bed.
stupid little videos, clips. All right, guys. I'm gonna hit the sack. So take care. And remember to share if you know anyone else that's doing it. The more people we get in the chat, the more interactive it is and the more fun it is. What the? Yeah, so I'm just putting stupid video clips in on the way through. So, yeah. All right, guys. I've got plenty more of those video clips as well. But I'm saving them for when there's lots of people in the chat. Take care.